Yeah, so welcome. Thanks for having me. My name is Moritz Dechamps. I'm a doctoral student at LMU Munich. Unfortunately, there won't be any flying objects in my talk, so please don't be disappointed. I'll still talk about the question whether the mind can influence the physical surroundings. And I've been doing research on this topic for the last 3 years in Munich, Germany, in my hometown, at the university, and I have found an answer in the last 3 years, and that is you can influence it sometimes when you're a smoker. And I'd like to show you in the next 20 minutes what I mean by that. But before we jump right into the minds of smokers and non-smokers, I'd like to talk about the relationship of mind and matter for a bit in general. So most would agree that the world as we experience it seems to comprise two distinct elements, the physical world and the mental world. And there are different ideas, though, if and how these two worlds interact with each other. So there's interactionist dualism that says the physical causally interacts with the mental and the mental does with the physical. And this goes pretty well with our day-to-day experience. Both these interactions are very hard to prove, though. So how can unique phenomenological experience, like a certain color, for example, can be explained by purely physical processing? And this is such a hard problem to solve that it became known as the hard problem of consciousness. And yeah, we already heard something about that, I think 2 days ago. The other way around is by no means easier to explain. So the influence of the mental world to the physical world, it's hard to think of a place where this could happen. And that's why there's other ideas of the interaction of those two worlds, for example, Epiphenomenalism, and that consequently gets rid of this connection. And this is basically the typical view of most modern science. So it states that the phenomenological experience is just a byproduct of the physical working, and that all causation can be reduced to fundamental physics. So no influence at all. And if this were to be true, one might ask, what about free will? What about morality if the mental world has no influence at all? And still, the hard problem of consciousness is a problem here as well. So there's yet another idea. It's psychophysical parallelism. And this gets rid of all problems that are caused by explaining causality, since the two worlds don't interact with another at all. They are, as Leibniz would put it, like two parallel clocks that lead to events being perfectly synchronized. And the reason for that, for Leibniz, was a pre-established harmony created by God. There might be another explanation, though, and that is the third underlying world that interacts with both the mental and the physical world, and this could be the quantum world. So what do we know of the quantum world, and how could it be that it interacts with both the mental and the classical physical world? Quantum theory possesses a number of very strange properties, and I only have time to go into one of them, and that's superposition. And this can be seen here. So this is a visualization of the double-slit experiment. That's the most famous quantum experiment. And in it, single particles like photons or electrons are shot at a plate with two slits. And what happens is that you can see a certain pattern behind the plate. So they form an interference pattern. And this means that the photon must pass both slits at the same time and interfere with itself. And this is what's called a superposition. So it's different states. It has different states at the same time. And in this case, it's at different places at the same time. And what's even more surprising is that this superposition vanishes when you measure the path of the particle. So in that case, it goes either through the top slit or through the bottom slit and just appears behind those slits. And what's unclear to this point is what constitutes a measurement. Or in other words, at what point of this interaction with the environment does this transition from the superposed quantum states to a single classical state take place? Is it when a camera is directed at the slits, when a computer is processing the path, or is it a conscious processing of the way of the result that has taken place? And this is a discussion held under the name of the Heisenberg cut, and there's still no answer to it. So what we know is there are a lot of different interpretations, though, that deal with this measurement problem, and some of them put more emphasis on the mental aspects and on consciousness in particular, like those I've highlighted here. And that means there is at least one solution to this quantum mechanical measurement problem that can explain this perfect synchronicity between those two worlds. And that would be that measurement is the conscious processing of quantum information. And if this is true, this would mean several things. This would mean superposition is still maintained in the subconscious. Subconscious processing would therefore have much more information at hand, would be incomparably more effective than conscious processing. And this is something we know to be true as psychologists. And since quantum information has no error of time, this would explain how subconscious anticipation of future events would be possible. So precognition and premonition could be explained by this. And the result of the measurement originates in the observer. And this leaves room for a subjective influence, for a subjective element, for an influence on which of the superposed state becomes real. And this leads us to micro-Psychokinesis. Micro-PK is researching the mental influences on inanimate probabilistic systems, and it can only be observed with statistical means, so not with the naked eye. And usually it's just the influence on random number generator, or dice, as we had heard before. And there's great, remarkable results that we have heard something about already. But there's still, it's still something that's not universally accepted, and there's several reasons for that. It has an unconventional high heterogeneity of the data, so some might believe that publication bias and other selection mechanisms are at hand. And even more important, there's an astonishing lack of direct replication attempts. So the most prominent example is the pair study that we already heard of. And there was a replication attempt of the pair study in Germany, by the way, at the Grenzgebiete Psychohygiene und Psychologie at Freiburg and Center for Behavioral Medicine at Gießen. And they only had rather disappointing results. They couldn't replicate the results at all. Non-significant result. And this led some to believe that micro-PK does indeed exist, but does not seem to be a very robust effect, that it cannot be replicated. And there's a second problem from my personal point of view, and that is that there's no consideration of the subconscious content in most of the designs. So usually designs are very explicit. It's usually something like try to get the RNG to behave in a certain way. And what has been shown is that effortless intention usually gets better result. And the crucial difference might be the intentionality itself. So we might get better micro-PK effects when the participants have a connection with the outcome on a deeply rooted, more implicit level. And that's why we decided to create such an experiment where the outcome matters to the participant on an implicit level. And here is where the smokers come into play. So we used the desire for cigarettes in smokers as our unconsciously driven state. And the idea of the experiment was that we have participants with a specific mental idea towards cigarettes, that is the need for cigarettes or a lack of cigarettes, that are connected via the quantum world to a specific, to the corresponding physical events, that is stimuli that address this need. And the quantum world is represented by a quantum-based random number generator, and that basically conducts a double slit experiment, and the slits are connected to outputting either 0 or 1, and in turn displaying either a neutral image or an image that has to do with smoking, a cigarette image. So that was our design. We tested 254 participants, and we hypothesized that the specific way the mind is set towards cigarettes within the smokers would lead to a deviation in shown cigarette-related stimuli and from chance, and we wouldn't expect such a deviation with non-smokers. At this point, I'd like to lose a few words about the statistical approach we used so that you can understand the results. We used the Bayesian analysis design, and Bayesian statistic works by updating your beliefs given new data and by pitting the likelihoods for the null hypothesis and the alternative hypothesis against each other. So usually you pre-specify a stopping criterion for the quality of the evidence, and you add data until this criterion is met. So it's a sequential design. And the evidence is measured with the base factor. That's just a relationship of the probabilities. So a base factor of 1 means there's no evidence towards either direction, and 3 is moderate evidence, and we use the base factor of 10, which means strong evidence. So I'll make it exciting and start with the non-smokers. No deviation from chance was seen here. You can see the base factor is going below 1, so in the direction of the null hypothesis, and yeah, we have moderate evidence for the null hypothesis, and this is what we expected. With the smokers, on the other hand, they experienced less cigarette pictures than the non-smokers, and if we look at the base factor, it shows a highly significant result. So the base factor was 66 in the end, and this means this result is 66 times more likely to be obtained under the alternative hypothesis than under the null. So the amount of pictures was different from chance. And yeah, we were pretty excited at this point, as you can imagine. It worked, and we decided to do a replication of this experiment. We pre-registered this replication. Everything was the same. We used the one-tailed approach this time. We had a clear prediction. Smokers see less than chance cigarette pictures. We tested 400 new participants. And yeah, I'm going to show you the results of the second study. So this is the non-smokers again, not a huge surprise. Again, in the direction of the null hypothesis. And now towards the smokers. So this time, the smokers showed no deviation from chance. You can see the effect was present at first, so the base factor goes up towards 10 at first, and then it quickly vanished and even went into the other direction. Yeah, so we were pretty bummed out by this result. We didn't get a replicable effect, but we still had the idea, this feeling that the smokers and the non-smokers data was somehow different. So what we did next is we looked at the data of both studies combined. And what you can see here on the left is the smoker sample, and there's a remarkable change in effect over the course of the time. That means the data that was added. So the base factor was in the middle of both studies, close to 600, which is really, really uncommon. Right? And there no such change in effect could be seen with the non-smokers, and no such change could be seen with the simulation as well. So could there be a micro-PK effect despite this lack of replication? And could we maybe further examine this decline effect? We already heard something about the decline effect and about the importance of novelty, and there's a theory that supports this idea. It's the model of pragmatic information by von Lucadou. But still we were asking ourselves, why would this happen? And let me walk you through our thoughts toward this. So we'll start with hopefully with a well-designed micro-PK study that leads to the emergence of a micro-PK effect in the form of a deviation from chance. And this deviation should violate the no-signal theorem in quantum mechanics, since information is basically created out of nothing. So where there should be randomness, and randomness means no information, there isn't randomness anymore, and therefore there's information. And this is a problem for the second law of thermodynamics. That says entropy must always increase, and order cannot come out of chaos. So what could happen at this point is that a counter effect is setting in to equalize this micro-PK effect and to make sure the information is lost again and the world is back in order. And as soon as this happens, everything can start over again. So with this idea, there's still a problem, and that's what's the difference between a real null effect and a decline effect. And we had an idea towards this as well, and that is that effect and counter effect are in a systematic interplay. So once the effect has been neutralized, the entropic counterforce also decreases, allowing the effect to reappear with a lowered effect than initially shown, and so on. And this interplay should lead to a temporal change in effect comparable to a damped harmonic oscillation. That's the blue line that you can see here. So effect and counter effect are in a systematic interplay. So was our data oscillatory? That's our data that's the z-scores, the cumulative z-scores of our data. That's pretty similar to the base factor. It's just upside down because the effect was negative. They saw less cigarette pictures. And we matched this data to a suitable damped harmonic oscillation. That's the red line. And this is the formula, and you all need to remember this. Okay, and if you continue to look at the oscillation, you can derive a prediction about the size of the future data. And that's what we did, and we decided to do yet another study, but this time we wouldn't look at the number of pictures, but if the temporal change of the effect follows our prediction. And we again pre-registered this study and tested 200 more smokers. Yeah, that's the prediction, and that's our data. So as you can see, it's not a perfect fit. I think it's a rather good fit. So as predicted, the effect gets weaker again. This means the line goes up and then gets stronger again. The line goes down again. Yeah, but it's hard to tell just by looking at it. So I conducted some simulations to compare this data to. That's just study 3. And those are the first 10 of 1,000 simulations. And yeah, as you can see already here is that our prediction is not very distinguishable. So it's basically just a horizontal line with a very small amplitude, and that's something that's very easy for the random data to follow. And yeah, that's what we see when we look statistically at the data. And that means 41.5% of the simulations have a better area under curve than our experimental data, which is an indicator for the fit. But if you look at the endpoint analysis, only 3.1% had a better prediction. So it's still kind of a success. And I'm still in the middle of analyzing this. So as soon as I'm finished, I'll publish it probably. Okay, the last thing I want to show you is the final Bayesian sequential analysis of all 500 smokers and this remarkable change in effect. And I wanted to know if this could be just a random fluctuation, if this happens all by itself. And so I once more conducted some simulations, and I urge you to take a look and to try to see if the lines go above 100. It's just a real rapid slideshow, just to get a feel of okay, rapid slideshow didn't work. So this is just one of those 100 simulations. It's the most extreme one. And as you can see, the base factor barely touches the 30, and yeah, never once did we experience a base factor close to 600. So that makes me pretty confident that what we found is really, truly special. Okay, so to sum up, in the first study, we found a micro-PK effect that can be understood as a particular mindset, a lack of cigarettes, that found through the quantum world its correspondence in the physical world. That means fewer cigarette pictures. Secondly, if measurement takes place through conscious processing, we should use deeply rooted, subconsciously active, independent variables, from my point of view. And finally, the problems replicating micro-PK can be understood as an entropic counter effect that together with the effect should form a pattern of damped harmonic oscillation. Yeah, thanks for your attention.
Thank you, and we have some time for questions.
Thank you for a very nice talk. Every time I see oscillations, I think of the possibility of correlating with geocosmic rhythms. So I wonder if you'd considered that as a possible influence on your results.
We haven't, no, we have not, but yeah, it's a good idea. Could try it, thanks.
I have 3 questions, but I'm going to limit it to 2. The first question in regards the studies conducted by the German institutions and you know, the Monte Carlo iterations. Do you think that was like a Hail Mary pass to try and find some structure in the data? And then actually the more important question I have for you is regarding the theory of the subconscious mind versus the conscious mind, like the conscious mind being that it has a kind of a method of collapsing reality and being specific and being very like directed and sort of, you know, and the subconscious mind, on the other hand, isn't aware of the conscious mind's impressions of reality. Are you suggesting that the subconscious mind, when people shut their conscious mind down, effects can be easier to obtain?
This is certainly a possibility. So there's one theory that's called the extended Everett concept, for example, and it says that in states where the conscious mind is not as active, for example, when you're sleeping, when you're dreaming, or when you're meditating, that you have better access to these different quantum possibilities and quantum information, and that you can try and learn how to extract this information into your conscious mind. Yeah.
So this was really interesting. Could you talk a little bit more about entropy and how this could possibly be related to the conscious mind and the subconscious mind? I'm thinking about some of Ed May's research that tries to look at the way entropy might be related to consciousness and awareness, and just curious if you could talk about that a little bit more.
So I looked at the book of Ed May earlier and saw that he wrote something about entropy, and I'm planning to buy the book and read it, but I'm not sure. I'm not familiar with what he had written. So the idea that entropy is the force that's responsible for the decline effect has now, from my point of view, has nothing so much to do with consciousness, but with the violation of the second law of thermodynamics, in a sense that you create information where information shouldn't be created.
Thank you.
Yeah, you're welcome.
So I'm wondering if instead of trying to fit a very specific curve through the results, if you've considered looking at a power spectrum of it of some sort and making predictions about where you're going to find peaks in that.
Yeah, it's definitely one of the possibilities. So as I was saying earlier, I'm still right in the middle of analyzing the last part of data. I've already only looked at the area under curve and some points, but we wanted to look at turning points as well and kind of local maxima. Yeah. So.
I'd like to criticize this notion, which, as far as I can tell, is a complete fallacy, that micro-PK somehow creates information because the entropy generated by the human participant simply by sitting there metabolizing and having a working brain is many orders of magnitude larger than the entropy decrease in the data stream where you're looking for PK effects. I've been sitting here creating highly organized notes on a piece of paper, and that information isn't appearing out of nowhere. It's powered by the entropy increase in my own muscles and physical nutrients. There's no reason to see PK as anything different.
Thank you.
When you're looking at the decline effect, the way you're doing it, the way it's traditionally done, is people do it sequentially. They do an experiment, then they repeat it, repeat it. What do you think would happen if you did 2, 3, 4, 5 experiments simultaneously, where you're recruiting to each experiment at the same time, but in a predetermined fashion, keeping the data separate? So you're actually doing the replication at the same time. What do you think you would get?
My opinion towards that is that it's important. That important is the time frame in which you look at the data. So responsible for this decline effect is the extent to which you get a confirmation of your effect.
So you're saying when you look at the data, suppose you did 5 experiments and had 5 groups analyze at the same time. Do you think you would get it? In other words, would this be a way around the decline effect? Because you're doing the experiments simultaneously, 5 replications, and you analyze the data simultaneously by 5 different groups at the same time.
Yeah,
would that be a way around it? I'm just, I would like your...
I hear you. I think it's a good idea. So maybe you could trick it somehow if you if the novelty is there for every research group, if every research group is doing the same experiment for the first time,
Yeah.
then you might get around it.
Well,
I'm not sure.
Maybe that's something that should be tried.
Yeah, thank you.
All right, thank you, Moritz.
Yeah, no worries.